Now we would look at general methods of production of fermented food products. As we earlier said that we have to look at the raw material or the starting food material, and that is given specific conditions for the growth of microorganisms. The selected microorganisms need to grow and produce the desirable end byproducts that produce the desirable fermented food products. So that end products would decide that what is the final product that we are interested in. For example, some of the bacteria, they might produce acetic acid or alcohol. So acetic acid would make up vinegar and alcohol would make up different alcoholic products. So that would depend, the end product would depend upon the type of bacteria and their metabolisms, and these would also decide what is the final product that we want to achieve. So if we look at the process of fermentation, it would be dependent upon the metabolic activities of microorganisms as well as the storage condition of the food. The microorganisms that we choose, as I earlier said, they are very critical for any kind of product because these are the microorganisms that would be bringing about all the desirable qualities within a food product. Fermentation, as we earlier said, it can be divided into three different types. It can be natural fermentation, it can be backsloping, or it can be controlled fermentation. We will discuss these, some of the merits and demerits of these technologies. For example, this natural fermentation, it can be a natural setting in which we do not add up our own specific type or strains of microorganisms within a food. Rather, the food would have natural microflora that might have the desirable microorganisms as well as undesirable microorganisms present within the food. And then we would give certain conditions in which the naturally present desirable microorganisms can show up activity. They can have a higher level of activity and growth, and they can suppress the growth of other undesirable microorganisms. Only in that condition we can make up a product that could be of higher value or that could have the desirable attribute. For example, the benefit of these kind of products is they would have a special aroma, because these special aroma would be coming up from a variety of microorganisms present in the natural setting, and the final chemistry or the composition of these products are very versatile. So that can give us very much unique aroma compounds at the end. But if we talk about the drawback of these kind of natural fermentations, of course, because they are natural, we cannot control, or we really don't know what are the different microorganisms present within that system. So there may be very much inconsistent results that can end up, because your final product would depend upon the natural growth of microorganisms. So they would be inconsistent end products, and every time the end product it might be different than the previous batches. So there is no uniformity, or in other words, the quality of these products would be variable every time. The second technique that is still practiced in many parts of the world, as well as traditionally most of the food would be utilizing this backsloping approach for fermentation or making fermented product. As I earlier said, that this is a method in which we take up some of the material from a previous batch of fermented product, and then this is added to a new batch. So this addition of previous material from a new batch would add up these starter culture bacteria or microorganisms into that batch, and this product would be normally this would lead up to a fermented product. For example, the way we make up yogurt from milk in our houses or in a domestic setting or in a smaller businesses, we can see that people always use some of the yogurt particles added to the new milk batch, and the yogurt is made by this technology. Again, this is not a kind of approach that would be producing very much uniform batches or uniform end products, so it could have variable results, as we can see in the natural fermentation process. So due to these factors, that natural fermentation process as well as backsloping methods can produce inconsistent results, and the modern day food industry is very much focused to produce a uniform product where the quality can be maintained and can be controlled, and every time you can enjoy the same level of quality of every product. So the new methods involve this controlled fermentation approach, in which we can control actually the starting material. All the raw material has to be heat treated in order to avoid the previous microflora or the natural microorganisms already present, and then it has to be inoculated with specific culture, normally with a high concentration, for example 10 raised power 6 cells per millimeter of the or more than that. So this culture is added to food that has been heat treated to inactivate the previous organisms, and then we may be able to add different strains together within this batch, and then large volumes can be fermented, and the end products are very consistent because we have actually controlled the quality of raw material, the number of microorganisms other than the desired starter culture that are there. They have to be inactivated, or the number have to be reduced, and then we control the conditions as well. So the end products are very much desirable. There are not many food safety issues, and the product can have uniform consistency. So these were the 3 different methods which are applied in domestic or small business, or even at larger scale businesses in the food industry.